Students, this is our final help video, Unit 8. It says find the area of the trapezoid. Trapezoid is going to be the two parallel sides, which we call the bases. Doesn't matter which one's 1, which one's 2. Area equals the average of the bases times the height, and height is the segment that creates a right angle. Average of the bases times the height. So for this one, it'd be 8 plus 16 over 2 times our height of 6, of course. And this is 14 over 2 times 6. That's going to be 7 times 6, 42. And then don't forget your units, yards squared. In the rhombus below, we are given the fact that EF DG is 9, and we want to find the area of the rhombus. Area for a rhombus equals diagonal, the whole diagonal, one diagonal, times the other diagonal, diagonal times diagonal over 2. So, if this right here is 9, this is 9, which means our first diagonal is going to be 18, times our other diagonal, which we don't have. But, because we have a rhombus, we have a right triangle here. Call that X. Have two sides, need a third side, Pythag. Our X is going to equal the square root of 225 minus 81. That's the square root of 144, which means our X here is 12. 12 and 12, which means our diagonal is 24. And we simply reduce. And our area equals 216 meters squared. So diagonal times diagonal over 2. Says a hexagon is circumscribed about a circle with a radius of 9 feet. There's two versions of this. There's one with the hexagon and another one with an equilateral triangle. So you make a picture equation. This would be hexagon minus circle, and this would be triangle minus circle. And because this would be an equilateral triangle, and it says right here this is regular, our equation is going to be, for both of these, perimeter times apothem over 2 minus pi r squared. So, in the equilateral triangle, it would be perimeter times apothem over 2 as well. This perimeter times the apothem over 2 minus pi r squared for the circle. Let's focus on this particular example. So we already have the radius of the circle. That's going to be 9. So this is 81 pi, and we're done there. For this one, we go like this. We draw in our radii. And our pizza slice here is 360 divided by 6, which would make this a 30, 60, 90 triangle. (30, 60, 90), short leg root 3, short leg times 2. Something times root 3 is 9. That's 3 root 3, which means our side length is going to be 6 root 3. So to finish here, our perimeter is going to be our side length, 6 root 3, times our number of sides, which is 6, times our apothem, which is 9, over 2. You can reduce that any way you want. I'm going to make this 3. So I have 6 times 3, which is 18 times 9. So we're going to get 162 root 3 minus 81 pi feet squared. And that is exact terms. Find the volume of the solid. It's just simply going to be volume. This solid is a prism. Base times height. And my base is a composite base, which are these two L's. That's my base. And height would be the distance between the bases, which in this case is 3. So this capital B, I'm going to slice and dice it. This shape right here, when I do that, watch very carefully. If this is 3 and this whole thing is 7, that means this edge right here is 4 and this edge is 5. So that would make this 20. And then I come down here, and this is 3 times 13, that's 39, which means my complete base is going to be 59. So it's 59 times 3, and my base volume is 177 feet cubed. Find the volume of the triangular prism. Again, this is base times height. There's my base. Volume equals base, and my height, distance between the bases, which in this case is 10. My base is going to be a triangle, so it is lowercase base times height over 2, and that's going to be 7 times 5 over 2. That's my base times my height, which is 10. That reduces by 5, so I have 7 times 25. And that's going to be 175 centimeters cubed. Solid object, it's solid, has a diameter of 5.8, height of 2 meters. Its mass is 27. What is its density? Density, just basic definition. Density is the amount of stuff compared to the amount of space. The amount of stuff over the amount of space. The official definition is density equals mass compared to volume. So at some point we need to find the volume here, which we're going to do. Volume equals our base times our height. Our base here is going to be 5.8 divided by 2. That's your radius. We're going to square it. Pi r squared, and then we're going to times by 3.14. And I get 26.4 4074 as our base. And then times our height, which is times by 2. And we get 528148. 52.8148. That's meters cubed. That's our volume. Our mass is 27 kilograms, so it's 27 kg divided by 52.8148. And it says right here, round your answer to the nearest hundredth. Do not round any other steps. So your density is 0.51, 0.51, and that would be kg, kilograms per meters cubed. Find the volume and in terms of pi. So volume equals base times height over 3. Our base here, our radius is 5, so that's going to be 25 pi times the height, which is 9, over 3. That means our volume is simply 75 pi inches cubed. Volume of a pyramid, volume equals base times height over 3. Our base is a rectangle, so that's going to be 9 times 8. Our height is 5 over 3. Reduce. So basically I have 3 times 8, which is 24 times 5. That's going to be 120. So volume equals 120 feet cubed. So right here, our radius is 6.1. Calculate the volume of the sphere, round your answer to the nearest tenth. So we take this 6.1, we're going to put it right there. So it's 4 times 3.14 times 6.1 times 6.1 times 6.1 over 3. It's important when you cube something that you cube that first. So we're going to work ourselves in our calculator working from right to left. So we start with the cube. So we're going to cube 6.1, there's your cube, times 3.14, times by 4, divide by 3, and let's see, we want to round our answer to the nearest tens place. That's 950.3, approximately 950.3 millimeters cubed.